Okay, so this is part two of the variance problem. So in the first part of the video, we were working with these five numbers, 7, 6, 3, 4, and 5. The mean was 5. We went through the four columns to calculate the sum of squares, which was 10. All right, so in this video, once we have the sum of squares, I'm going to show you how to calculate variance and the standard deviation. So the formula for variance is the sum of squares divided by df. All right, so df is called the degrees of freedom. And the textbook definition of the degrees of freedom is this. Degrees of freedom is simply the number of items that are free to vary. All right, that's super abstract, and honestly, we're not going to go into the level of detail. We're not going to go into too much detail on the theory and the definition of degrees of freedom. So basically what you need to know in this class is how numerically we're going to define degrees of freedom for every problem. And when we do variance like this and basically all the way up through the first exam, the formula for degrees of freedom is going to be simply n minus 1. Now that is going to change moving forward, but for now and all the way through the first exam, degrees of freedom is simply n minus 1. So if the overall formula of variance is sum of squares divided by degrees of freedom, and for now degrees of freedom is n minus 1, then variance is the sum of squares divided by n minus 1. All right, so all we're going to do now is plug in our numbers. So our sum of squares is 10. N in this problem, I didn't rewrite this, but remember n in this problem was 1, 2, 3, 4, 5. So n minus 1 is 5 minus 1. So 10 divided by 5 minus 1 is 10 divided by 4, which is 2.5. All right, so the variance in this problem is 10 divided by 4, which is 2.5. All right, once we have variance, we can calculate standard deviation. So standard deviation is simply the square root of the variance. So we're going to take the variance from up here, which is 2.5, and get the square root of that. And the square root of 2.5 is 1.58. All right, so in this problem with these five numbers, we have a mean of 5, and sum of squares of 10, variance of 2.5, and a standard deviation of 1.58. Now, what do those numbers mean? So what does it mean when you have a variance of 2.5? What does it mean when you have a standard deviation of 1.58? Well, I think the easiest way to understand what it means is to do another problem where we don't have numbers that are so tightly clustered together. Because remember, when I introduced the idea of variance, the idea of variance is looking at how the items vary. And you can see when you look at this data set, the smallest number is 3, the largest number is 7. There's really only a 4-point range here. These numbers are really tightly clustered together. So we have this relatively small variance, relatively small standard deviation. What happens if one of these numbers is way outside of the range? What happens if we have an outlier? And so in the second problem, I'm going to show you how the variance and standard deviation change when you have an outlier.